Row 1. Text, Notepad window, text editor, editing, blank. Remember, this is not teaching teacher. It is useful for recalling, when exam coming student. Just close eyes and listen. Based on G scheme for Electronics Engineering Group. Subject, Digital Communication, 17,535. These are mostly important questions which is always repeat. Form top to end it, reduce repeated changes. X question 1 is more important than 2 in notes. And note warning sign that this is not all chapter.
Digital Communication Chapter 2. 1. B. State Sampling Theorem. Explain aliasing effect with neat diagram. ANS Theorem, 1 mark, aliasing effect diagram, 1/2 marks, explanation, 1/2 mark. Sampling theorem states that a band-limited signal of finite energy having the highest frequency component FM Hz can be represented and recovered completely from a set of samples taken at a rate of samples per second provided that Fs greater than or equal to 2 FM. Where Fs equals sampling frequency, FM equals maximum frequency of continuous original signal. Aliasing effect: if the sampling rate Fs 2Fx, undersampling, then the sidebands of the signal overlap and information signal xt cannot be recovered without distortion from sampled signal, XSF. This distortion is referred to as aliasing or fold-over distortion. Here the sideband frequency from one harmonic will fold over or overlap with the sideband frequency of another harmonic as shown in Nyquist rate. The minimum sampling rate of 2 FM samples per second for a signal xt, having maximum frequency of FM Hz, is called as Nyquist rate. A. Draw the neat block diagram of PCM transmitter and receiver. Explain the same with waveforms. PCM transmitter diagram, 2 marks. Digital Communication Chapter 2. 2. Fig. Block diagram of PCM transmitter explanation, 1 mark. The analog signal/modulating signal xt passes through band limiting/low pass filter, which has a cutoff frequency Fc equals W Hz. This will ensure xt will not have any frequency component higher than W. In other words, suppresses high-frequency components, and passes only low-frequency signal to avoid aliasing error. The band-limited analog signal is then applied to sampled and hold circuit, where this circuit acts as modulator, and both modulating input signal and sampling signal with adequately high sampling rate are inputs to this circuit. Output of sampled and hold block is a flat-topped PAM signal. These samples are subjected to operation quantization in the quantizer. Quantization is a process of approximation of the value of respective sample into a finite number that will reduce data bits. The combined effect of sample and quantization produces is quantized PAM at the quantizer output. The quantized PAM output is analog in nature. So to transmit it through digital communication system, the quantized PAM pulses are applied to an encoder, which is basically A to D converter. Each quantized level is converted into n-bit digital word by A to D converter. The communication system is normally connected to each other using a single cable, i.e. serial communication. But the output of ADC is parallel, which cannot be transmitted through serial communicating links. So this block will convert the parallel data into serial stream of data bits. A pulse generator produces train of rectangular pulses of duration t seconds. This signals acts as sampling signals for the sample and hold block. The same signal acts as clock signals for parallel to converter. The frequency f is adjusted to satisfy the criteria. PCM receiver diagram, 2 marks. Fig. Block diagram of PCM receiver. Digital Communication Chapter 2. 3. PCM receiver explanation. 1 mark. A PCM signal contaminated with noise is available at the receive input. The regeneration circuit at the receiver will separate PCM pulses from noise, and will reconstruct original PCM signal. Cleaned PCM is fed to a serial to parallel converter. Then applied to a decoder which converts each codeword into corresponding quantized sample value. This quantized PAM signal is passed through a low-pass filter, recovers the analog signal waveforms. A. Draw and explain adaptive delta modulation. Transmitter block diagram. For MANS, block diagram of adaptive delta modulation transmitter, pulse generator produces train of pulses. Variable gain amplifier and square law device controls the capacitor charging as per the input signal. If input signal varies slowly or is constant in nature, the charge on the capacitor will be zero due to reverse polarity pulses generated, so amplitude of output pulse of variable gain amplifier will not change, and thus help in reduction of granular noise. If input signal varies steeply, the capacitor will be either positively or negatively charged, so amplitude of output pulse of variable gain amplifier will increase with some factor, and thus help in reduction of slope overload effect. Thus in ADM, wide range of analog signal can be used due to variable step size and have better utilization of bandwidth. Waveform of adaptive delta modulation transmitter. Digital Communication Chapter 2. 4. ADM waveforms. B. Describe the concept of slope overload distortion in a DM system. Draw neat waveform. How it can be avoided. ANS, slope overload error 1 marks, waveform -2 marks. How to avoid -1 mark, if slope of analog signal xt is much higher than the approximated signal xt, over a long duration than xt, will not be able to follow xt at all. The difference between xt and xt is called slope overload distortion. Thus the slope overload error occurs when slope of the xt is much larger than slope of xt. ADM waveforms. B. Describe the concept of slope overload distortion in a DM system. Draw neat waveform. How it can be avoided. ANS, slope overload error 1 marks, waveform -2 marks. How to avoid -1 mark, if slope of analog signal xt is much higher than the approximated signal xt, over a long duration than xt, will not be able to follow xt at all. The difference between xt and xt is called slope overload distortion. Thus the slope overload error occurs when slope of the xt is much larger than slope of xt. Avoidance of slope overload. The slope overload error can be reduced by increasing slope of the approximated signal xt. Slope xt can be increased, and hence the slope overload error can be reduced by either increasing the step size or by increasing the sampling frequency. The slope overload error can be reduced by increasing slope of the approximated signal xt. If slope of xt can be increased, and hence the slope overload error can be reduced by either increasing the step size delta or by increasing sampling frequency fs. B. Explain companding. Sketch the input-output characteristics of a compressor and an expander. ANS, explanation 2 marks, characteristics with explanation -2 marks. The combination of compressor and expander is known as compander, which performs the companding process. It is used to increase the signal to quantization. Digital Communication Chapter 2. 5. Error ratio for weak signal. The figure shown below is the schematic block diagram of companding. Compression at the transmitter side. Fig. Schematic block diagram of companding at the transmitter end. The information signal is passed through compressor, where the signal is amplified more at low amplitude than at high amplitude. At the receiver side, an inverse operation is performed to recover the original information signal. This is achieved by an expander. A. State any 2 advantages and 2 disadvantages of PCM system. ANS, advantages, any 2 marks, 1. PCM has very high noise immunity. 2. Repeaters can be used between the transmitter and the receiver, which can further reduce the effect of noise. 3. It is possible to store the PCM signal due to its digital nature. 4. It is possible to use various coding techniques so that only the desired receiver, user, can decode the message. Disadvantages, any 2 marks, 1. The encoding, decoding, and quantizing circuitry of PCM is complex. 2. PCM requires a large BW as compared to other systems. Digital Communication Chapter 2. 6. A. Write about advantages and disadvantages of delta modulation. For MANS, advantages of delta modulation: 1. Low signaling rate. 2. Low transmission bandwidth. 3. The delta modulator transmitter and receiver are less complicated to implement. Disadvantages of delta modulation: 1. Slope overload distortion. 2. Granular noise. 4. Compare digital pulse modulation with analog modulation. ANS, any 4 relevant correct points, 1 mark each. B. Draw block schematic of DPCM transmitter and receiver. ANS. DPCM transmitter. Digital Communication Chapter 2. 7. B. Describe the process of quantization with neat sketch. ANS, explanation 02M. Quantization is the process of approximation, or rounding off the sampled signal. The quantizer converts sampled signal into approximated rounded values consisting of only finite no of pre-decided voltage levels called as quantization levels. In the process of A to D conversion, after sampling, quantization is the next step. The input signal xt is assumed to have a peak swing of VL to VH volts. This entire voltage range has been divided into Q equal intervals each of size S. S is called as step size, and its value is given as S equals VHVL/Q. Diagram of the process quantization is as shown below. 1. Draw and explain block diagram of delta modulation. ANS, 04M diagram TX, 04M explanation TX. In Fig. 1, the input analog is sampled and converted to PAM signal, which is compared with the output of DAC. The output of DAC is a voltage equal to regenerated magnitude of the previous sample, which was stored in the up-down counter as a binary number. Digital Communication Chapter 2. 8. The up-down counter is increment or decrement depending on whether the previous sample is larger or smaller than the current sample. The up-down counter is clocked at a rate equal to the sample rate. Therefore, up-down counter is updated after each comparison. Initially, the up-down counter is zeroed, and the DAC is outputting 0V. The first sample is taken, converted to a PAM signal, and compared with 0 volts. The output of comparator is a logic 1 condition, plus V, indicating that the current sample is larger in amplitude than the previous sample. On the next clock pulse, the up-down counter is increment to count of 1. The DAC now outputs a voltage equal to the magnitude of the minimum step size, resolution. With the input signal shown, the up-down counter follows the input analog signal up until the output of the DAC exceed the analog sample. Then the up-down counter will begin counting down until the output of DAC drops below the sample. Amplitude or explanation DM transmitter. It consists of a comparator, single but quantizer, and an accumulator connected together as shown in Fig 2.12a. In delta modulation we compare the present sample xn of the message signal xt with an approximation to the previous sample and the difference between xn and is applied to a single bit quantizer. If the output of the comparator is positive, whatever may be the actual magnitude, quantizer gives an output of plus, and if the comparator output is negative, quantizer output will be dash. When equals, it is binary 1, and whenever equals, it is binary 0. This sequence of is encoded by the encoder. Digital Communication Chapter 2. 9. A. Explain the role of predictor in differential pulse code modulation. For MANS, in DPCM, if the redundancy is reduced, then the overall bit rate will decrease, and the number of bits required to transmit one sample will also reduce. This type of digital pulse modulation technique is called differential pulse code modulation. The DPCM works on the principle of prediction. The value of the present sample is predicted from the previous samples. The prediction may not be exact, but it is very close to the actual sample value. ANS, Limitations to MKS, Elimination Method Explanation to MKS. Overcoming of DM Drawback by ADM. Digital Communication Chapter 2. 10. ADM Transmitter. Waveforms.